This is a video for the complement rule for at least one. Now, I've tried to say this before, but the complement rule never has to be used. You can always do a problem without the complement rule. The complement rule will just save you lots of times, usually. So let's look at this problem. So we're looking at 4-digit pins that you use for like an ATM pin or your debit card pin. And so you just have, for each digit, you can choose numbers between 0 and 9. So there's 10 possibilities for each digit. So we want to know, what is the probability of getting a 4-digit pin with at least one 0? You could do this directly the long way, and to do this you have to figure out what are all of the possibilities to get at least one 0. So I represented these with zeros and x's. So a 0 is for the 0 and an x is for something that is not 0. So for example, if you want to get a 1 0, you can do a 0, not 0, not 0, not 0, or a not 0, 0, not 0, not 0, not 0, not 0, 0, not 0, or not 0, not 0, not 0, 0. So these are all the ways you can get 1 0. But if we're looking for at least 1 0, you also have to consider, how could I get 2 zeros? Notice there are 6 different ways that I could get 2 zeros. Then for 3 zeros, there are 4 different ways. I could do 0, 0, not 0, or 0, 0, not 0, 0, or 0, not 0, 0, 0, etc. Okay. And then for 4 zeros, the only possibility is 0, 0, 0, 0. So look at all of these possibilities of ways that I could get at least 1 0. There are 4, 6, 4, and 1 more. So that gives me 15 different ways that I can get at least 1 0. So if I want to do this the long way without using the complement rule, I need to find the probability for each one of these, and then when I'm done, I have to add them up. So let's figure out, how would I find the probability for the first one? So for 1 0, for the 0, not 0, not 0, not 0. Well, let's look at the first digit. I want a 0. What's the probability of getting a 0? There are 10 numbers to choose from, all equally likely. So the probability of getting a 0 is 0.1. Now using the complement rule in just this one step, if the probability of getting a 0 is 0.1, the probability of getting a not 0 is 0.9. And to get the next not 0, I need a 0.9, and the next not 0 is a 0.9. Okay, now the reason I multiply is because I need a 0 and, keyword there, and another not 0, and another not 0, and another not 0. So whenever we're looking for the probability of an and, we need both things to happen at the same time. We multiply. When I multiply this out, it gives me 0.0729. Let's multiply the next one. So this next one, for a not 0, that would be 0.9. And then I need a 0, which is 0.1. Then a not 0, and then another not 0. If I multiply that out, it will also give me a 0.0729. Let's say I wanted to do this event right here, for 0, 0, not 0, not 0. Well, a 0 would be 0.1, another 0 would be 0.1, the next one would be 0.9 for not 0, and 0.9 for not 0. Let's see what that gives me. That gives me 0.0081. And so do you see what I'm going to have to do here? I'm going to have to find the probability for each one of these possible 15 outcomes and add them up. Notice this is going to take a really long time, but you could do it this way. And it takes a lot of work though. Or we could use the complement rule. Okay. So what is the complement of at least 1 0? The complement of at least 1 0 is no zeros. So let's find the probability of no zeros. Well, what outcome is in the event no zeros? The only way to get no zeros in a 4-digit pin is if you have not 0, not 0, not 0, not 0. So the probability for that would be 0.9 for the first not 0 times 0.9 for the next not zero, times 0.9 for the next not zero, times 0.9 for the next not zero. So if we multiply all these together, we get 0.6561. So that was just to get the probability of no zeros. Now I still want to find the probability of at least one zero. The probability of at least one zero is going to be 1 minus the probability of no zero. So 1 minus the probability of no zeros, or 1 minus 0.5 or 6561, which gives me 0.3439. So if you have a 4-digit PIN, the probability of getting at least one zero in there is going to be 0.3439, so about 34%. Notice one more time, I could do this problem without the complement rule, but I have to find each of the 15 possible outcomes that give me at least one zero, find the probability for each one of them, and then add them up, which would take a long time. So we use the complement rule, find the probability of no zeros, and then subtract that from 1.